Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. So in today's class, we are going to discuss some numerical problems on equivalent resistance using star to delta and delta to star transformation. In the previous class, we have already discussed how to how to find the equivalent resistance between any two terminals for a given electrical network. So, which means, as we know already, if the two elements are connected in series, then we just the resultant resistance is by sum of the two individual resistance. And when the two resistors are in parallel, then the reciprocal of the resultant resistance, which is equal to the sum of the individual reciprocal resistance of the individual resistances. So here, and also in the previous class we have discussed how to identify the series connection of the resistors and how to identify the parallel connection of the resistance. So for the series connection of the resistance, if the two resistors having one common node and the common node does not share with any other element, then we can say those two resistors are in the series connection. And similarly, coming to the parallel, when the two resistors having two common nodes, then we can say those two resistors are in the parallel combinations. But suppose, okay, so if these two conditions are not exist, okay, not satisfied, which means let us consider a simple example here. So like here R1, R2, So here of course R1, R2 having only one common node, but the common node is sharing with the resistance R3. So that we can't say R1, R2 are in the series connection, right? Then what about the parallel condition? The parallel condition, here the two resistors must have the two common nodes. But here these two resistors having only one common node. Okay, so which means either we can't define, okay, so neither series nor parallel. Then in this case, how to reduce the network to find the equivalent resistance between any two terminals, right? So in that case, then we are going for the star to delta or delta to star transformation, right? So this topic also we have discussed, so you can go through my previous videos so that you will get to know so how exactly the star is transformed into delta and delta is transformed into star. But here I am just writing what is that, just for the a simple reminder, I am just writing the equations. Okay, so the star to delta and delta to star equations, right? So here this is a delta. So this delta, suppose if you want to convert into the star, right? So let me just write here, inside this delta, let me draw this circuit. So here this one and this one, and here this one. So what we just mentioned, this is R1 that we are calling, and this is R2, and this is R3, right? Okay. So now, because this is delta to star transformation, right? Okay. So delta to star transformation. Delta to star transformation. So in delta to star transformation, so which means we know the value of R12, R31, R23, but we don't know the value of R1, R2, R3. So in this case, how to find this value here? So first, suppose if you want to find the R1, so here R1 is connected to node 1. So what are the two resistors, other two resistors which are connected to the node 1, which are R13 and R12. So then here R13 and R12, R13 into R12 by the total resistance here R12 into R12 plus here R31 plus here R23. This is what R1, right? Similarly, if you want to find the R2, right? So here R2, what are the two other resistors which are connected to the second node here? R12 and R23. So then here R12 into R23 by similarly again R12 plus R31 plus R23. Then the similar way here, if you want to write R3 is equal to, So what are the two resistors which are connected to R3 here? R31 and R23. So here R31 into R23 by, okay, again the total resistance R12 plus R31 plus R23. So this is how the star to delta transformation. Sorry, the delta to star transformation. So because now we are converting we are having the delta and the delta having the three resistors, and we know the three resistors values. Then if you want to transform the delta into star, then the star, what is that connection having again three resistance, let us consider R1, R2, R3, then the value of R1, R2, R3 are like this. So this derivation we have already discussed in the previous classes, so you can just go through the previous videos, then you will get to know how we got R1 is equal to R13, R12 by R12 plus R31 plus R23, something like this, right? Now suppose if there is a star, okay, now this star that we are transformed into delta, then how we can? So which means here let us consider here delta, right? So here now star to delta, right? So then in this case, yes, now star to delta. So now we know the value of R1, R2, R3, but we don't know the value of, let us consider here it is again, which is in between R12, so R12, and again here it is R23, and here it is R31. So suppose if you want to find the value of R12, okay, then here R12 is equal to R1, R2 plus R1, R3 plus R2, R3 by the opposite resistor, which here it is R3. So then R3. Then similarly here, if you want to find R12, then R23. Okay, the numerator is here again same R1, R2 plus R1, R3 plus R2, R3 by, okay, by the opposite resistor, here it is again for this opposite resistor is R1. Okay, or in another words, if you simplify this, okay, so you will be having here R3 is there and here R3 is there. Okay, R3 gets cancelled. Then okay, so here in between 1, 2, R1 and here R1, R2. So R1 plus R2. Okay, or let me write here itself so that you will won't get confused. So here this, if you simplify, you will get R1, R2 by R3 plus R1, R3 by R3 plus R2, R3 by R3, right? So here R3 gets cancelled, R3 gets cancelled. Then you can write this one as R1 plus R2 plus R1, R2 by R3. So either you can write this way or you can write this way. Okay, both are same. So when here R12, because R12, so what are the two resistors which are combining to these what is that? Because R12 is in between 1 and 2 nodes, and the resistors which are connected to 1 and 2 nodes are R1 and R2. So R1, R2 plus R1, R2 by the opposite resistor R3. Similarly, suppose if you want to find R23, then R2 plus R3 plus R2, R3 by R1. Simple, right? Then similarly here, if you want to find R31, so R3 plus R1 plus R3, R1 by the remaining resistor, here it is R2. Okay, so like this you can transform star to delta and delta to star, right? So now we are going to some practical examples. Yeah, here it is one. So first let us see, okay, so whether any two combinations are series or parallel. Okay, suppose let us go with these 4 ohms and 4 ohms. This 4 ohms and 4 ohms. Of course, these two resistors having only one common node, but this common node is connected to here this 8 ohms resistor. So which means here these two are not parallel, sorry, not series. And let us check with parallel combination. Okay, of course these two are having only one common node because it doesn't have two common nodes, so these two are not parallel even. So these two we can't define as a series or parallel, right? So then let us go with another combination. Then here this 4 ohms and this 8 ohms. Of course, these 4 and 8 again having only one common node, but this common node is connected to this 4 ohms resistor. So which means, because according to the series condition, the two resistors must have only one common node, and the common node does not share with any other element. But this common node is already connected to with 4 ohms resistor. So we can't say these two are in series. Of course, parallel also we can't say, because here it is having only one common node. Similarly, okay, if you go with these 4 ohms and 6 ohms, again these two are having only one common node, but the common node is connected to 8 ohms resistor. So we can't say these two are in series. Similarly, again the combination, here it is 8 ohms and 6 ohms. Again the same problem, here one common node and the common node is connected to the 4 ohms resistor. So these two also we can't say series or parallel. Then again the final one, here it is the 8 ohms and 4 ohms, right? Here 8 and 4 ohms are having only one common node, but here the common node is connected, because we should find the equivalent resistance between A and B terminals. Suppose, of course, here A 4 and 8 are having only one common node, but if you just make it as a series, then you are going to eliminate this point. Then, because here we need to find in between these 2 points only, so that's why we should not eliminate this point. So that's why we can't make it these two are in series. Then in this case, okay, then how to reduce the network, okay, to find the equivalent resistance between the two nodes A and B. Okay, so then now we are going to transform, okay, or apply the star to delta, delta to star transformation. Of course, in the given problem, they have already given the hint, okay, so that we can convert these delta into the star. Okay, we can convert this delta into the star, right? Then if you want to convert this delta into the star, okay, so which means here the delta connections, let us consider here it is RA, RB and RC, right? So now if you want to write RA is equal to, so what are the two resistors which are connected to these RA? 6 ohms and 8 ohms. So that's why here 6 into 8 by the total resistance, here it is 6 plus, here it is 6 plus 8 plus 4. Then similarly RB. So here it is RB. What are the two other resistors which are connected to this RB node? Okay, 4 and 8. So that's why 8 into 4 by 6 plus 8 plus 4. Then similarly here RC. So RCR, this is the RC, okay, connected to this particular node, and our other two resistors connected to this particular node are 6 and 4. 6 into 4 by, again 6 plus 8 plus 4. Right. So let us see the values of this. Okay. So here then 6 plus, here 8 plus 4, which is equal to 18. Okay. So in the denominator, all are 18. Right. Then here 6 into 8 divided by 18, which is equal to 2.66. 2.66. Okay. So and again here 8 into 4 divided by again 18, which is equal to 1.77. And again here 6 into 4, this is 24. 24 divided by, here it is 18, so which is equal to 1.33. Right. So here then here RA is equal to 2.66, RB 1.77 and RC is equal to 1.33. Then this network will become, let us draw here, because let us for your simple understanding, let us consider here it is this is A and this is B and this is C. Let us consider the nodes. So in between RABC we are connecting the RA, RB and RC. Okay, so this is, let us consider the O. Fine. So now the remaining resistors as it is here I am drawing. Okay, so here it is 4 ohms, right, and here it is again 4 ohms, right. So here it is node A, and again here it is 8 ohms, and here it is node C. Okay, and then somewhere else here it is node B. Okay, and here it is connected to this one. So here A, and of course here is also B, and here is also B. Now here it is a O, right? So A is connected to A terminal, and B is connected to the resistor B is connected to B node and C is connected to C node, right? So these values are here, it is 4 ohms that they have already given, and here also 4 ohms, and here it is 8 ohms. Then RA, so RA is 2.66 ohms, and RB is equal to here 1.77 ohms, and RC is equal to here 1.33 ohms, right? Now let us see. Okay, so again check with this network whether any two resistors are in series or parallel. Of course, now here you can see these 4 ohms and 2.66 ohms are in series. Okay, so that you can eliminate the point A. Then here 4 plus 2.66. Okay, so here it is 6.66 ohms. Again here these 8 and 1.33 are in series. Okay, so that you can eliminate this C point. So here then 8 plus 1.33, so here it is 9.33 ohms, right? So now let us draw again the circuit here itself, because now we have finished this one. Then let us draw the circuit here itself. Then the circuit will become, then here the circuit will become here. Of course, again the 4 ohms is as it is. Okay, and here because the point O is there already. Okay, so then in between this point and O point, then you will be having only one resistor, and let us consider here it is O. Okay, and in between these two again you will be having only one resistor. Okay, so here again C is eliminated, so this point is make it as same as it is, and here you will be having one more resistor, and here it is the point B. Okay, then here you are having one more point, that is B again. This is A. So this is 4 ohms, and here it is 4 plus this 4 plus 2.66, here it is 6.66 ohms, and here 8 plus 1.33, here it is 9.33 ohms. Okay, and here it is as it is 1.77 ohms. Okay, so this network is transformed into this one, right? Now again let us see. Okay, again any other combinations. Of course, as you can see here, these 6.66 and 9.33 are in parallel, because these two are having two common nodes. So this is one common node and this is another common node. So then the equivalent resistance will be 6.66 into 9.33 by 6.66 plus 9.33, right? So here then 6.33 into 9.33, okay, so which is equal to here 59.05, then 6.66 plus 9.33, so which is equal to 15.99, then here 659.05 divided by 15.99, which is equal to 3.69, so which is equal to 3.69. So then these two can be replaced with one single circuit. Okay, I mean one equivalent resistance. Then here you will be having A and B. So here A is equal to 4 ohms and B is equal to, here it is 3.66 and C is equal to 1.77. Now as you can see, these three are in series. Then here 4 plus 3.66 plus 1.77, then which is equal to plus 4 plus 1.77, which is equal to 9.46, which is equal to 9.46 ohms. Then here RAB, which is equal to 9.46 ohms. So this is your answer, right? So here, I mean, of course, some circuits may require what is that in a single circuit you may require 2 to 3 conversions, which means one may be star to delta, again delta to star, something like that. You may it may require to convert. In some networks, okay, so one time, I mean, at any place, okay, if you want to convert, if you can convert star to delta, delta to transform, then you can easily simplify the circuit. And another thing here that is one more important point. Here there is no compulsory like we should convert only this particular this particular delta, okay, into the star. Of course, as you can see here, this is also a delta, so this delta can be also converted into star, right? Which means here, let us consider here, okay, these are the 3 points, okay, 1 2 3, okay, so this is 1 point. So here, as you can convert this one also, then by using this also you can solve 1 2 3, right? So by converting this delta into the star, that is also possible, right? So or otherwise, okay, here this star can be also converted into delta, because as you can see, by making this 1 and this is 2 and this is 3, so these three resistors having 1 point, so that we can make it as a star. So this star can be also converted into delta, right? So how we can convert? So in between you will be having one resistor in 1 and 2, okay, in 1 and 2 you will be having one resistor, right? And in between, let us consider here it is 1 and here it is 2 and another star, okay, so here it is 3, right? So in between 1 and 2 and again 1 and 3 also you will be having one more, okay, because here it is there. And in between 2 and what is that, 1 2 and 3, okay, in between 2 and 3 also you will be having one more resistor. So in this way also you can make it the star to delta conversion also, right? Then coming to the next problem. So here simple, they have already given, you just see, okay, this is one star connection, the star can be converted into directly into the, sorry, this is a delta connection and delta can be converted directly into the star. So which means again here, let us consider here one resistor and second resistor and third resistor, right? So let us consider here again, it is RA and here it is RB and here it is RC, right? So here I'm just writing the what is that, the equations, okay, directly. So Ra is equal to Ra. So what are the two resistors which are connected to this particular point? 8 into 8 by, okay, so 8 into 8 by, so here 8 plus 16, which is equal to 32. So R 8 plus 8 plus 16. Then similarly, RB is equal to, so RB 8 and 16. So 8 into 16 by again 8 plus 8 plus 16. So this step is important. Okay, once if you are able to write this, I mean, you're able to find the delta to star transformation, then after that again simple like the series and parallel combination, so that we can reduce the network and so that we can find the equivalent resistance between these two terminals, right? Then here RC is equal to 8 into 16 by 8 plus 8 plus 16, right? Okay, so then here 8 into 8, that is 64, okay, divided by 32, then which is equal to 2 here. Then here 8 into 16 divided by 32, which is equal to 4 here, okay, so which is equal to also 4 here, right? So now then let us draw these reduced network, okay, so which means here A and here it is B and here it is C, right? So yeah, already A B is there, okay, but let us just write, okay, R, instead of this here you can just make it 1 2 3, okay, so that is not a problem. Then here already 1 ohm is there and in between here it is 1 ohm is there, right? So then here as it is and here it is also as it is, okay. Then here you will be having, or just let me uh, draw like this, 1 and 2, okay, and here in between one more resistor is there, okay, one more resistor is there in between. This is converted into delta, okay. Then here it is 1 ohm, okay, and here what we have considered here Ra and Rb and Rc here. So here again 1 ohm is there and A is 2 ohms and B is 4 ohms and C is 4 ohms, Okay, then again RA and this is B. Okay, so then I'm just removing these because again we no need to confuse AB. Right. So now again, as you can see, okay, how to find these two networks. Okay, how to find these two networks. Here, as you can see, directly here it is a delta, so that's why directly we are transforming into a star. Okay, right. But even though, let us think whether without converting star to delta, okay, or delta to star, is there any possibility? So first we should check that one. Okay, then after that we should go for the delta to star or star to delta. Okay, because if there is, if we cannot identify, okay, or if we cannot define whether the two resistors are connected in series or parallel, then only we will go for the star to delta and delta to star transformation. But it doesn't mean like if there is a network, okay, which is looks like delta, then we should go for the star, right? Because as you can see here, these 1 ohm and 8 ohm resistor, okay, so these 1 ohm and 8 ohm resistor, so whether these two are connected in series or parallel, these two are connected in parallel because these two are having two common nodes. This is one common node, okay, and this is another common, okay, so that we can make it this one as a one equivalent resistance. And here another thing, these 1 ohm and 8 ohm also connected, okay, in between these two terminals, okay, so that we can also make it these two are parallel, so that we can make it as a one equivalent resistance, right? Okay, so it is very easy, even we no need to go for the star to delta, delta to star transformation. That's what here I just want to tell you, right? We no need to go, because suppose if you go star to delta, delta to star transformation, then we are making it more complicated. So because here again there is no possibility to convert what is that possibility to convert or to reduce the network, right? Because as you can see here, these 1 and 2, okay, having one common node, but this common node is connected to 1 ohm resistor, and here these 4 and 2 also one common node connected to this resistor, okay, so which means we came into the reverse manner. So that's why without, okay, checking the combination, okay, so we should not go for the star to delta, delta to star transformation, right? Yeah, so which means now it doesn't require this transformation, because directly here there is a possibility, okay, or there is a condition that satisfying that parallel condition of that particular network. That's why here then simply here 8 by 8 divided by 8 1, right? Because here 1 into 8 by 1 plus 8, 1 into 8 by 1 plus 8, so here 8 by 9, so then this one 8 divided by 9, so which is equal to 0.88. Then this is also here 0.88. Then this network will become 1, and here again one more resistor A, this is, and this is B, and here this is one more resistor, right? So here it is 0.88, and here it is 0.88, and here it is 16 ohms. Then these two are in series, okay, so here 0.88, okay, 0.88 into 2, okay, so which is equal to here 1.76. So 1.76 and 1.76 is in parallel with 16 ohms resistor. So here 1.76 into 16, which is equal to 28.16 by, okay, so here 17.76, then divided by 17.76, which is equal to 1.58. So here RAB, which is equal to 1.58. Very simple, right? Now we will go for another problem. Yeah, here again, as you can see, first let us check with whether any series and parallel combinations are there, because without checking again it will more complicate. So Here this 20 and 1K having one common node, but the common node is sharing with again this 500 ohms. Of course, this 500 and 2.2K one common node and share with 1.5 ohms, and 1K and 2.2 having one common node, but the common node is connected to that point B. So that's why here we can't get the condition, okay, to identify whether the two resistors are in series or parallel. Then we will go for the star to delta, delta to star transformation, right? So here I'm just going for star to delta, because before we have seen that delta to star. So now here for simplification, so I'm just converting this star into delta conversion. Right, this star into delta conversion. So when you are converting this star into delta conversion, then let us consider here it is. Let us consider, of course, A, B already there, na? So A, here it is B, and here it is C, right? So let us consider here it is R1, R2, and R3. Fine. So then here R1 is equal to, right? So what are the two resistors which are connected to R1 here? I mean R1 here. Okay, what are the two other resistors? No. These are not R1, R2, R3, because already we know these values. So yeah. Then the same way here it is RAB. Okay. So RAC. This is R, not RAB. RAC, and here it is RAB, and here it is RBC. Right. So now we need to find, first let us find RAB. Okay, as we know, RAB is equal to RA plus RB plus RARB by RC, right? Okay, then RA means the resistor connected to the node A, so which is equal to 200, plus RB is the resistor which is connected to the node B, which is 1K. Okay, so 1000 plus, and RA 200 into 1000 by, here RC is 500. This is the value of RAB. Then similarly RAC, and RAC, directly I am writing RAC. So here RA is 200 plus C is 500. Okay, plus 200 into 500 divided by 1000 1K. Then similarly here RBC is equal to, here RB is 1K. Okay, so which means here again 1000 plus 500 plus 1000 into 500 by, again here it is 200, right? So now we need to find these values. So here let me find first these values. Okay, then here 200 into 1000 divided by 500, so which is 400 the value. Okay, I mean 400. Okay, and plus 200 plus 1000, so here it is 1600, so which means 1.6K. Okay, so 1.6K ohms. And here again which is 200 into 500 divided by 1000 plus 500 plus 200, so which is equal to 800 ohms, right? Then here it is 1000 into 500 divided by 200 into, I mean not into, plus again 1000 plus 500, which is equal to 4K ohms, right? Now this network is reduced into, because in between A and C there are two resistors, 1.5K and RAC, right? So in between these two there are two resistors, right? And in between A and B again one more resistor, A and B, and in between C and B already this resistor is there and one more resistor is there. Okay, so here like this. Okay, then this is like this. Yes, 1 2 1 and 2. Okay, and one more resistor is also there here, because this is RB, R, AB, RBC, and this 2 point all are connected to this point B only. So that's why here one more resistor is also there here, right? So this is 1.5K, and here it is RAC. RAC is 800 ohms, and RBC here it is RBC here it is 4K, and here it is 2.2K again, and here it is RAB, which is equal to 1.6K. So here A and B terminals. Now as you can see, these two are in parallel and these two are in parallel, right? Then here I'm just writing here, as you can see. So here you will be having one equivalent resistance, and here you are having as it is one more resistor, and here you will be having one more resistor. So here again A and B. Okay, so here it is 1.6K, and here the combination. Okay, so 1.5K is in parallel with 800, and here it is 4K is in parallel with 2.2K. Then again these two are in series, and this series combination is in parallel with this one, then so that you will get the RAB, right? So this is how we can find the equivalent resistance. Now here we have converted the star into the delta, right? So which means either delta can be star, or star can be delta. So that you have to what is that identify, okay, which transformation that we should apply to reduce the network, so that we can find the equivalent resistance between the two terminals, right? Then now we are going to, of course this is also simple, but let us go with another problem. Okay, so this you can solve by yourself, because here also let me just tell you, uh, either you can convert any what is that the star into delta, or delta into star. So as you can see here, this is delta, and this delta can be converted into the star. Okay, or one more thing here, by using these three combinations also you are having one star. So this star also can be converted into the transformed into the delta. Okay, or even though this star, okay, especially this star also can be converted into the delta, so that I mean, because compared to all, this is very easy. So here one, this star, okay, this star can be converted into delta like this. Okay, and here, right? So after that then it is very easy, because now these two are in parallel and these two are in parallel. Okay, and this combination and this combination, this and again these three are in series. Okay, like that you can what is that convert the star to delta transformation. Then after that you can apply the series and parallel combination, so that you can find the equivalence, the resistance between these two terminals. Let us consider here 1 and 2. Fine. Then next here also the same way. So now you can see here it is star. Okay, again this star also can be converted into delta, right? So then after that here, as you can see, these two combination are parallel, and these two combination are parallel, and again these two, the combination of these two parallel are in series, and again this combination is in parallel with this, then this combination is in series with this 4 ohms, so that you can easily find, right? Then now here it is. Now we need to find the equivalent resistance between these two terminals A and B. One is left hand side, another one is right hand side. Then how to what is that identify, or how to solve this problem? Here it is also very easy, because as you can see already, okay, these three are in series and these three are in series. Okay, so which means here this 3 and these 3. So now this network can be reduced something like, okay, so 2 plus 2 plus 3. So here it is 2 plus 2, 4, 4 plus 3, 7. Okay, and again here 5 plus 2, 7, 7 plus 4, 11. So then this network can be transformed into here 1, 2 ohms is there. Okay, and again here 1, 3 ohms is there. And of course, let us find, and one more here 4, 7. So here in between you will be having only one resistor. Let us consider here it is 7, and in between here it is one more resistor, and here you will be having one more resistor, and here also you will be having the 5 ohms resistor. So here this is like this, and here also you will be having like this. So here it is A again, and here it is B again. So this is 2, and this is 3, and this is 6, and this is 6, and this is 5. So here it is 7 ohms, and here it is 11 ohms. Here it is 11 ohms, right? So then after that, is there any possibility? No, there is no possibility. So that's why now we can convert these delta into the star now. Okay. So 1, 2, and 3. Okay. So if you can convert this delta into the star, so as you can see here, now these are in a what is that series, and this combination and and these two combinations are again, I mean these two are in series. Okay. So like that, I mean again these two, because it is eliminated, so these two can be also in series. So something like that you can convert, because now this and this will be going to eliminate. So now these two will be in series, and these two will be in series. Okay. And these two will be in series. Again, these two combinations are in parallel. Okay. And this parallel combination is in series with this one. Okay. So like that you can reduce the network, and you can find the equivalent circuit. Okay. So let us find here. Okay. Then, right. So here, now let us consider, here it is R1, R2, and R3. So here R1, which is equal to 3 into 6 by 3 plus 6 plus 6, and R2 is equal to also 3 into 6 by 3 plus 6 plus 6, and R3 is equal to again 6 into 6 by 3 plus 6 plus 6. Okay. Then here 18 by here 6 plus 6 12 and 15. So here again 18 by 15, and here 36 by 15. Okay. Then here 18 divided by 15, which is equal to 1.2, and here also it is 1.2, and here it is 36 divided by 15, so which is equal to 2.4, right? So now this network can be, now I'm just going to eliminate this. So this one and this one and this one, right? Okay. So now you will be having one resistor here and one resistor here. Okay. And R1, R2, R3 values that you can write here. Okay. Then here this R1, R2, R3 can be written as, okay, as this total network can be reduced something like this. So this 2 ohms, and here one resistor is there, and here again one more resistor is there, and here one resistor is there, and 3, of course, yeah. Then here there is no other resistor. Okay, fine, right? Now, yeah, here one more resistor is there. 3 resistors are there. Okay. Right. So here 6 into 6 means here it is 2 point. Here it is 2.4, and here it is 1.2, 1.2, and here it is 2 ohms, and here it is again the 11 ohms is there, and here it is 5 ohms, right? So now here this 1.2 and 2 are in series. Okay. So here you can make it, because again here it is A is there. So here this is 3.2 by these two combinations, and again these two combinations also, here you can write it as 12.2, and again these two combinations. Okay. So here you can write it as, here it is 7.4. Okay. Then again here you will be having one more resistor. Okay. And here you will be having this B. Okay. And here you will be having this A and B, right? And again here it is 7 ohms resistor. Now let us see, okay, any two resistors are in series and parallel. Yes, of course, here these 12.2 and this 7.4 are in parallel because these two are having, this is one common node and this is another common node. These two are having the two common nodes, so you can make it okay. So here this 7.4 into 12.2, okay, so which is equal to here 90.28 by here 7.4 plus 12.2, so which is equal to here 19.6. So that here the equivalent resistance here it is 90.28 divided by 19.6, which is equal to 4.606. Right? Then again this 4.606 plus 3.2 are in series. Okay, plus 3.2, which is equal to 7.80. So then here 7 into 7.80 by 7 plus 7.80. So this is your total answer, which is RAB. Right? So this is how we can apply the star to delta and delta to star transformation. So in the next class, we will discuss the another topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.